Sup, fermions. In our today's video, we'll learn more about what is centrifugal force. What is it? Or is that actually a force? Let's find out. To understand centrifugal force, we have to understand what is centripetal force. And I do know that many of you might be knowing what is centripetal force. Then bravo, you must write your name in comments. Now let's begin with a joke. There was Newton sitting on his chair and said, "Hey, let's make classical mechanics much more tougher." So he made centripetal force. Now you can laugh. I am trying to be funny. Let's do an experiment. Take a ball, tie it to a string, and then suspend the ball. After doing it, try giving it a little flick so that ball revolves around your hand. Then the question arises that why does the ball revolves instead of going in a straight direction? Many of you must be very obvious in giving the answer that because we flicked in that sense or that it may revolve. But physics is not that easy. The answer is centripetal force. But how? Let's understand. Listen carefully. Imagine the whole path as a circle, the whole path of the ball revolving as a circle. Then draw an arrow in the direction of the force you applied through your wrists. Now, the direction in which the force is being applied through your wrist, mark it with an arrow pointing towards that direction. You mark another arrow in which direction the ball went. Now, before going any further, we'll firstly learn about what is parallelogram rule of vector addition because it's one of the most important part in learning what is centripetal and fugal forces. See, now I'm giving you a kind of idea about that what was I saying. Imagine this circle as a path of that ball. This is the string attached, right? And I'll use this shape to make the ball. I guess this shape is right. Have you ever seen a pentagon ball? Neither me. But I guess it would work. And one more thing. This string is not from string theory. Pretty obvious. Now, this is the ball. This is the string attached. In and it is going in. You applied the force in this direction or kind of this direction. Your hand is there and whatever. But you see that the ball is going actually in this direction. Kind of this. Making a sort of tangent of that circle. Going in this direction. So this is the force you apply, or this is the resultant force. Some third party force would also be working here. Let's see what is it. Yeah. Parallelogram rule of vector addition. Vectors. The measurements in physics that are in regards with direction. For example, velocity, displacement. Now let's consider a boy named John. John observes us going from point A to point B. He asked me, uh, how fast were you going? I said, very fast. And he was like, how much? And I said, 10 miles per hour. And he was like, boom. Really? That fast? Second time he asked me, when I came back from point B to point A, then he asked me, now in which direction you went? I said, east. In the first case, he asked me about my speed. In the second case, he asked me about my velocity because in second case, he also asked what is the direction, 10 mile per hour and east. Now, these vector quantities cannot be added normally. There is a specific way for it, like parallelogram rule. Parallelogram rule of vector addition. Here it comes. Now, in this type of vector addition, we mark the direction of the acting force with an arrow. The first force, we mark it with an arrow to represent act, to represent its direction in which it's acting. Then we add the other force. Oh, I forgot to add N over here. Silly me. Add force by joining the backside of the force of the that these first force and the second force, like kind of this, making a beautiful angle over here. Such a lovely one. Then make a parallelogram by extending the shape made by two forces. So these were our two forces, and this is our hypothetical or imaginary extra lines that were added to make it a complete parallelogram. In parallelogram rule of vector addition, then make a diagonal connecting the back side, like wait a minute, yeah, here make a diagonal. This will tell you the direction of the force in which it acted and also bit of magnitude. So to calculate it, there is a very pretty long formula, that is p square is equal to a square plus b square plus 2ab cos theta, where p is that resultant force, a is that first force, b is the second force. And what is theta? Theta is the angle between these two forces. Now here's the fact. Whenever you are dealing with a case in which the parallelogram is actually a square, I mean with 90-degree side, then instead of long multiplication, division, addition, subtraction, and whole bunch of these mathematical operations, you can just convert into root 2 simply and multiply it by the thing, because cos 90 is 0, this wall will be 0, and then you will multiply it giving it by root 2, and that all will work kind of. Then back to the circles. Now in a diagram we also made an arrow to represent its resultant force. Here we can calculate the result. Here we have resultant force, so we can calculate the second force. Now I'll tell you how. See, we get to know that this was our resultant force, this was our actual force, the first force. And now we'll put the value of these in this and the formula. And to calculate B, what we have to do is actually using quadratic equation, that ax square plus bx plus c is equal to 0, that one. We'll use it, and we can also find the theta by making kind of angles and all parallelogram rules, whatever. So now the most important part of the circle, we see that there is an inverse force. Like see, after calculation you will see that here, let me this make these are the center. The force would be acting in like kind of this way towards the center. Yeah, towards the center. So scientists after this observation concluded that there is an inward pull of an object when we make it revolve around a particular axis. What is it? Well, you must have guessed it right. Centripetal force. Then how to calculate it? The formula is centripetal force is equal to mv square by r, where r is the length. This length is r. All right. So we'll come to centripetal force. Time for the big deal. Now there is another term named inertia. That is the tendency of an object to resist any change in its state of motion or rest. As we know in our previous conclusion that there is an inward pull whenever you just apply force in front direction. There is there is also a kind of change in state of motion. That means inertia resist, tendency resist. Inertia resist change in state of motion. And what centripetal force is causing? Change in state of motion. So that resistance converts into an outward like pull. And that outward like pull then seems or is perceived like centrifugal force. So basically, it is actually inertia, not any other force, that is giving that outward pull. What a big deal he made. Real life examples: revolution of Earth around the Sun, pretty obvious. Stirring of tea in cup, and we stir the tea from the center, and these particles inside the tea are pushed towards the cup. Spinning amusement park ride, car turning of car. In these both areas, there is you feel an outward pull. So see, this was our video till here. This was our video till. I want you to support us so that we can make much more better video. I know this was our first video, so I was not that comfortable. Well, I guess I would be habitual of it and do my best to increase your knowledge. So please subscribe to Buddy Fermion. Thank you.